moving on to part 2 of weeks 3 to 4, we are going to discuss angles formed by intersecting chords, secants, and tangents. These are the concepts. I'm not going to read it anymore, but we are going to go back to these concepts when we are solving for the examples. So we can identify what concept are we going to use and how to go about it. So these are the examples. So for example number 1, we have two intersecting chords. This can be two intersecting secants as well. The focus is where the point of intersection lies. And in our first example, the point of intersection is right here, which is clearly inside the circle. So therefore, let us go back to the concept and look for inside right here. So the measure of angles formed by secants can be chords intersecting inside the circle is half the sum of the measures of the intercepted arcs. So therefore, we have to identify the intercepted arcs of the angle that we are looking for, get the sum, and half of that is the measure of the angle. So let's proceed to solving. So we are looking for the measure of angle BOC since x is right here. As what we have found out in the concept, that is half the measure of the intercepted arcs. Where are the intercepted arcs of angle BOC? The intercepted arcs are this arc right here and that arc right there. Because this clearly is an intercepted arc. However, this angle that we are looking for and this angle right here are vertical angles, so they have the same measurement. That being said, arc AD can also be considered an intercepted arc. So let us now proceed to our solution. So we will have here the measure of arc BC. Let's quit this Grammarly. Plus, half the sum daw, sabi kanina, di ba? Measure of arc AB over 2. So this will be our equation such that we can identify the measure of angle BOC. Substituting the values, the measure of arc BC is 71 and the measure of arc AB is 129 over 2. So that is 200 over 2, which will give us the measure of angle BOC, which is equal to 100 degrees. That is our final answer. Again, it doesn't really matter that much if the segments are secants or chords. What matters is the point of intersection. Where does the point of intersection lie? Say for instance, in our second example, this is a secant and a tangent, but the point of intersection is right here. And obviously that is a point on the circle. So therefore, going back to our concept, we have to look for on, and here it is. So the measure of angles formed by secants intersecting on the circle is half the measure of its intercepted arc. So unlike in our first example where we need to add the measures of the intercepted arcs, this time around we only have one intercepted arc, which is in this particular case arc BA. So what we want to do is to just get half of that. Therefore, we will have the measure of angle BAD is equal to the measure of its intercepted arc, this particular case, that is the measure of arc BA over 2. So what is the measure of arc BA? That is 124 over 2. So therefore, the measure of angle BAD is equal to 62 degrees. That is our final answer. Lastly, we have this example right here, and obviously, it is different from the first two examples because the point of intersection is outside the circle. Let us assign names to the points. Say for instance, this is S, H, I, F, T. And we are looking for the angle formed outside the circle. So let us go back to our concepts, and obviously the third one is outside. So the measure of angles formed by secants intersecting outside the circle is half the difference. So if the secants or chords intersect inside, that is half the sum. If the secants, or in this particular case can be tangent, secant and a tangent, or it can be two tangents, intersect outside the circle, then we have two intercepted arcs, but we have to get half of the difference of the intercepted arcs. So therefore, the measure of angle SIT will be equal to the measure of the bigger arc, that is the measure of arc ST, minus the measure of arc HF over 2. Why is it that in our first example, we were not conscious about the bigger arc and the smaller arc? It's because addition is commutative, meaning if we change the places, let's say for instance, 4 plus 3 is 7, 3 plus 4 is still 7. So it doesn't really change anything. However, in subtraction, we have to subtract the measurement of the smaller arc from the bigger arc. If not, we will have negative values, and we are looking for measurements, and that cannot be. Anyway, going back to our solution, we'll have the measure of arc ST, that is 72 degrees. Minus the measure of arc HF, which is 22 degrees. And divide it by 2. So 72 minus 22, that is 50 over 2. So the measure of angle SIT is equal to 25 degrees, and that is our final answer. Again, going back to our concepts, when the secants or chords intersect inside the circle, so we just get half the sum of the intercepted arcs. So we will have two intercepted arcs, add the measurements of those intercepted arcs, and divide it by 2. If the secants or chords intersect on the circle, we will have just one intercepted arc. Get half of the measure of that intercepted arc, and that is already the measure of the angle. Lastly, if the secants or tangents intersect outside the circle, then we will have two intercepted arcs. What we want to do is to get the difference, so the bigger arc, minus the smaller arc, then get half of that, and that is the measurement of the angle.